Hello, and welcome to Algebra 1. We are going to run what is called a flipped classroom, where you will have weekly lectures online that you'd watch at home or on a mobile device, and we will have time to do extra practices and extra work in the classroom, and that gives us more time to work one-on-one with you, the students. This is our Week 1 video notes for Algebra 1A. A relation is a set of information that is ordered. Usually that is shown in algebra as ordered pairs. The domain is a set of all the inputs in our relation, so in our ordered pairs. When you do an input, that is usually the x value. The range is the exact opposite. The range is our set of our outputs. Usually when you plug an x value in, you get the output of the y value of your relation. Here is an example of 5 ordered pairs: 2, 3, -1, 5, 4, -2, 9, 9, and 0, -6. When you're asked to give the set of all of the domain of this relation, you're going to open with a bracket, not a parenthesis, and you are now going to list all of your x values in numerical order from smallest to greatest, so it's called ascending, and you list them out and close it with an ending bracket. In this case, my domains would be 2, -1, 4, 9, and 0. So in numerical order, from smallest, the -1, up to our greatest, which was a 9, I would have to list -1, 0, 2, 4, and end with 9 and close this with a bracket. It's very similar when I have to go through and do the range. The range is just the y values, which are 3, 5, -2, 9, and -6. However, it does have to be ascending, so I still have to go from our smallest of the -6 up to our greatest of the 9. This order would be -6, -2, 3, 5, and 9, and close it off with a bracket again. There are 3 other ways that we can look at ordered pairs and relations. The first one is called mapping. So if I had a map that looked like this, over here on the left of the very first side, this is my domain. I would input this domain into whatever equation we're using or whatever rule we're using, and I would get these values out. These are called our range. So when I go through and take this mapping and build it into our second form of looking at relations, a table, I would start with my x value of 1, which maps or has an arrow pointing it down to the y of 6. Our x of 2 maps to 2. Our x of 3 maps to 4. Our x of 4 maps to 8. And finally 5 maps to 10. Another way to look at our relations is to look at a graph. This graph we still have to fill in. I've seen the mapping for a set of values. Our relations had our domain and range here. We turned it into a table. So now I'm going to plot the 5 ordered pairs. 1, 6, 2, 2, 3, 4, 4, 8, and 5 goes all the way up to 10. We can now rewrite this as a set of 5 ordered pairs. The ordered pairs I'm going to put in brackets because we're listing them out. And it started with 1, 6, 2, 2, 3, 4, 4, 8, and ended with 5, 10. I'm now going to close this bracket off, saying I am now finally done listing out all of my ordered pairs. Another word we need to use more in algebra than we did in Intro to Algebra is the word function. A function is a relation where each element or each value in our domain is paired with exactly one element in our range. In easier words to think of it, each x has exactly one y. So I'm actually going to highlight this so you guys can see it, and hopefully you'll highlight it along with me so it stands out for you. We need to figure out now in our next example, are each of these three sets of ordered pairs or relations, are they a function? When I look at this one, I have 0, 1, 2, and 8 for my domain or my x values. None of them are repeating, so each one of my x's has to go to each one of my y's. So the answer is yes. This first example is a function. In the next example, I have 0, 1, 2, 8, and 9 for my domain or my x values. There are no repeats, so each x has to go to exactly one y. So once again, yes. That one is a function. And in my third example here, I have 3, 1, 2, 8, and 3 again in my domain. There is an issue because I do have the x value or domain of 3 repeating itself. Now I have to ask, this x goes to 2. This x goes to 5. Do each one of those x's have exactly one y? The answer in this case is no. So I have to write no for this third example, and I highlighted why not. 3 does not go to exactly one y. I can also tell if a relation is a function based on the maps. I've sketched in 2 maps for you for example 4 and example 5. Pause the video at this point to go through and make sure that you copy the exact same mapping down that I have. We need to ask ourselves, in example 4 right here, is this map a function? We need to make sure, is this truly going to map out so that each x has exactly one y? So we need to go through, and there are 2 things we want to ask ourselves first. We must make sure we've used all the x's. So let's go through and double check in our map. Did we follow that rule and use every x? Yes, I did. Does each x value go to exactly one y? There's only one arrow coming off of each and every one of these. The mapping is nice and visual. So the answer for this one is, yeah. Each x went to exactly one y. What that means is this relation a function? The answer is yes. It is a function. In example 5, I have a mapping once again. I need to figure out, is this relation truly a function? I'm going to look through once again and make sure, did I use all of the x's? I did. There's nothing sitting there empty, so I'm going to check that one off. The x value can only be assigned to one y. So once again, I'm going to make sure in my domain, there's only one arrow coming from each line. 1's good. 2 isn't, because 2 actually maps to 4, and it's trying to also map down here to 10. Now 3, 4, and 5 were all fine. However, there's already a problem because I have an x value, I have a value in my domain that goes to 2 in my range. So the x value can only be assigned to one y. I'm going to put a note in here for you so you can see why this is not a function, but 2 was assigned to both 4 and 10. So when we're asked the question, is this relation a function? The answer in this case is no. It is not a function. We're going to go on to page 3 now. Here I have two tables that we need to see, are these relations functions? Pause the video at this point to make sure that you fill in both of these tables just as I have. We're going to go through and work with the one on the left first. We need to ask ourselves, is this relation a function? And I'm going to tell you right away, yes, this one is a function. How do I know? Here's how I can figure it out. I look at all my x's, -2, -1, 0, 1, and 2. None of my x's repeat, so each of my x's must have only one y value. So when I ask you, how do you know? Each x value has exactly one y value. There are no repeating x values is another way to look at this. It's also the easier way to look at any sort of our mappings or our tables. So I'll write that one down here as well. And now we're going to go on to our second table. In this table, when I look at it, I have my domain here and my range here. When I look at this right away, I see something that stands out to me. I see that in my domain, I have two 1s. I have a repeating x value. My x of 1 goes to 2 and to 6. So when you are asked, is this relation a function? In this case, the answer is going to be no. And I know because I have 1 as my x value repeated. So there is an x equals 1 twice. X equals 1 maps to both our 2 and our 6. They're different y values. I cannot call that a function. Another way to look at relations is to look at them in their graph form. In examples 7 and 8, I've given you a handful of values here in ordered pair form. I have already graphed them. I would take a second, please pause the video and graph each of your points. I'm now going to look at example 7 first. I'm going to ask you, is this relation a function? Example 7, yes, this one is a function. And here's how I know. When I look at my x values, -4, 1, 2, -1, -6, 4, 0, and 3, there are no repeating x values. So that means for each x value, there is only one y value. When I look over here at example 8 now, I see that I still have the same number of ordered pairs. But when I look up here, I see my x value of -4 repeated twice. So when I look, when x is -4, there are two x's with different y's. I also look up here and I see that 4 is repeated twice. So when I go to 4, here's one x value with two different y values. So when I look at example 8, if I were to ask you, is this relation a function? In this case, the answer is no. And how do I know? I'm going to start it off with exactly what I just said. When x was -4, there are two different y values. When x was -4, I had both -4, -6, and I also had -4, 3. If that wasn't enough, I have a second time that this is proved to not be a function, and that's when x equals 4. When x equals 4, once again, there are two y values. Because when x was 4, I had 4 comma 1, and I had 4 negative 1. So when I ask you how I know, I would accept either or both of these. Now we're going to move on to the last page of our notes for today. We're going to talk about what is called an inverse. Inverse is used a lot over the next several years of your math career. Inverse relations are obtained by switching the coordinates. So basically what that says is we are going to take our domain, and that's going to become our range. And that also means the range is going to switch and become the domain. So of course I wouldn't let you be without an example. Our final example of the day is example 9, where I'm going to give you this relation. In this relation, there are 6 different coordinates in ordered pairs. First thing, I cannot make an inverse if my set is not a function to start with. So I have to ask myself, is this a function? Well, I have 1, 4, negative 3, negative 4, negative 1, and 0 for my input, my domain, or my x values. Because none of them are repeating when you're asked, is this a function, the answer is going to be yes. How do I know? Because each x is assigned to one y. So now when I ask you, please give me the inverse of this relation, you're going to start off with those brackets again, listing out all of our points. And I'm going to take that first set. My first point is 1, 4. I am going to switch them, so I'm going to take the 1 and the 4 and flip them around. That makes it now 4, comma 1. So this next one, when I switch my x and y around, I'm going to have 6, comma 4, followed by 2, negative 3, followed by negative 2, negative 4, 5, negative 1, and ending with 0, comma 1. Or I'm sorry, 1, comma 0. Trying to talk while pointing. And now that I've listed them all, I'm going to end that with a bracket. You also have to ask yourself, is this inverse a function? When I look at it, I have 4, 6, 2, negative 2, 5, and 1 in my new domain. I have no repeating new domain values and no repeating new x values. So because of that, is this inverse a function? Yes, it is. I'll see everyone in class tomorrow.